Start.
Hi friends, how are you? I am Mehbar Khan from Delhi, and I want to show you my project which I have made on proteus based fault detection system. In my project, I have shown two types of faults: under voltage fault and over voltage fault. These are the apparatus which I am using in this project. You can see I have used R1, R2, R3, R4 of values 10k, 1k. These are 4 in numbers, 2 quantity each, and 6 capacitors. 4 capacitors of C1, C4 of 1000 microfarad. 100 microfarad, and 2 capacitors C5 and C6 of 1000 microfarad, and 4 integrated circuits. Number 1 at Mega 16 7805 ULN 2003. These are ICs at Mega 16, ULN, and Max 232. These are my 3 ICs. Mainly my microcontroller is based on at Mega 16. This IC I am programming, and 1 transistor, 3 diodes, and 12 other miscellaneous things. Buzzer, LM016, COM pin, and reset start RL1, RL2, RB1, RB3, TR1, TR2, and I have used 2 transformers also. This is the overview of my circuit. I have designed this circuit to perform 2 tasks, mainly over voltage and under voltage detection. This circuit detects when in our line we find under voltage or over voltage. I have set the values under voltage as 180 voltage and over voltage as 220 volts. And I want to show you the circuit in detail. As you can see here, this is my transformer. I have stepped down my power supply of 220 volts to 12 volts and converted it using bridge rectifier and converted it to DC, and I have used this capacitor here to smoothen the supply of DC supply. And this supply, I will tell you later about this all supply. First you can see here my IC and these connections. This is my IC, and you can see this is my at Mega 16 IC. I have connected all the circuits using this. You can see here I have connected my Max 232 to it, and is ULN 2003A with it. This I have connected to it to 18, 19, 20 and 21 port, 21 pin number to its 1, 2, 3, 4 pin number. And these are the relays, the under voltage relay and over voltage relay. These are the 2 relays, and this Max 2 ULN 2003 is a relay driver, mainly relay driver. It drives the relay. It takes 5 voltage from this at mega 16, and this 5 volt is converted to 12 volt to run these relays. These relays operate on 12 volt. This relay driver, this is the relay driver IC. This helps these relays to run on 12 volt. It takes the signal according to our programming from it, this IC. This IC gives the signal to it, and this relay driver operates these relays. As if you are getting under voltage, then this relay operates. If you are getting over voltage, then this relay operates. Same as here, LCD is connected to, this is the potentiometer. I have connected potentiometer to it to adjust the contrast of the LCD. This is my 16:2 LCD, and this LCD is connected to my IC, and you can see here that this also operates on 5 volt. It also operates on 5 volt, and this IC also operates on 5 volts. And I have added one potential divider here, which this is a potential divider. This potential divider gives the supply, DC supply of 12 volts come into this potential divider, and this supply, this breaks the supply, means divides the supply into 5 volts, and this supply goes into this 5 volt supply goes into this LCD and my IC at mega 16, and this max 232 IC. And this IC works on 12 volt, so it takes directly current, direct 12 volt current from the main supply. These are my COM ports. You can see these are the COM port which I have used to connect to my PC. I have connected this IC mainly is used to take the input from what input is coming in my LCD. What input comes in my LCD, that input is shown to my laptop or computer through this COM pin. This is that LCD is connected to this, and this is connected to this IC, and this IC drives this COM pin. So let me show you I'll show you my programming later. First of all, secondly, I want to show you my circuit, original hardware which I am using. This is my hardware. As you can see, I am having 2 transformers. As you can see, I am having 2 transformers. These are hello friends, I was discussing my software, and now I am going to discuss my hardware to you. Let me show you the complete hardware which I have made according to that circuit which I have shown to you. Now you will be getting more idea about the project when you will see the hardware, that how it's working and what are the things it's controlling and doing. This I am going to show to you. Yes, as you can see here that I am getting supply of 230 volt. Means whatever supply I am getting, that supply I have stepped down to 12 volts here using this step down transformer. This is step down to 12 volt. Now I am explaining you about this circuit, this whole circuit I am going to explain you. that this I'm getting my 12 volt supply here, and this 12 volt supply is converted. This is LED which is glowing, as I can see, you can see that I'm getting the supply here, and these are the diodes which are connected. These are made bridge rectifier to convert the AC supply to DC supply. And this is my capacitor which is used to smoothen that 12 volt DC supply, and that DC supply is given to this potential divider and given to that this IC. This IC also operates on 12 volts, and this 12 volt comes to this potential divider, and it is divided into three 5 volt supply which goes to this LCD. This is my Atmega 16 chip microcontroller, and this is my Max 232 IC. This is the whole combination of Max 232 IC. Here, these are the capacitors. These are the capacitors. As you can see here, a small capacitor, four number of capacitors are connected to it. You can use Max 233 also, in which the capacitors are inbuilt. And these, wherever I have connected these resistance, these are for the current limiting. These are limiting the current. This is potentiometer. You can see here, this is potentiometer, 5 volt. It operates on 5 volt, and here it controls the contrast of this LED, this LCD. And you can see here this is my potentiometer. You can see here this potentiometer is of 5 volt, and it controls the contrast of this LCD. As you can see here, if I'm changing the potentiometer, this is changing the contrast. You can see here, put more focus. This is my potentiometer, and these are also my potentiometers, 2 potentiometers. You can see these are also my 2 potentiometers. These potentiometers are used to control these 2 relays. I have used used 2 relays for over voltage and under voltage, and these 2 relays I have put for further increasing of my project. I'm further using this project, extending this project, and then in that project I'll be using some more factors like current and frequency. Here in this project I have used only over voltage and under voltage, so for that I have used these relays. And now I'm going to completely explain my full supply, how it's working. This 12 volt is coming here and it's converted to DC. It's coming here and converted to DC, and again this is smoothened by this capacitor, and this 12 volt comes to this potential divider, and this potential divider converts the 12 volt to 5 volts, which goes into this LCD, and this potentiometer, and this Atmega 16 microcontroller, and this Max 232 IC, and this IC operates on 12 volt. This IC operates on 12 volts. and this takes supply from the here directly. It takes supply from here directly, here to here, here to here. It takes directly supply, and it is mainly relay driver. You can see it is mainly relay driver. This relay driver drives these relays. Is used to drive these relays, and these are my reset and stop and reset button, which are used to reset, and I am pressing this button. You can see here proteus based fault detection is coming over there, and now I want to and this is my rectifier. Oh, this is my sorry, this is this operates on 12 volt, and this is a 10k. Its value is 10k, 12 kilo ohms. It works on 12 kilo ohms, and this is connected to this buzzer. This I have connected to the buzzer. This IC is connected to this, and this is connected to this buzzer because it's an amplifier. It's amplifying. It is taking 5 volt from here, and the 5 volt supply, and because this buzzer works on 12 volts, so this 5 volt of supply, when it gives 1 or 0, when it's give 1, then means if my this relay is operating, then it gives 1 to this, and it checks the condition, then it the buzzer beeps, and when my over voltage occurs, then also this my microcontroller IC gives 1 or 0 to it, and then again it operates. Let me show you more about my project. As you can see here, this is my, here you can see this transformer. This transformer is used as transducer. This is giving here 12 volt, same 12 volt also. It's also giving 12 volt because I am working making a large project on and making it small and working on DC. So I have used I have stepped down the supply to 12 volt. This transformer is used for my circuit, for the running of my circuit, and this transformer, this transducer, it's used for the calculation of my means, as how can I show you that my over voltage is coming or under voltage is coming. So when I will make it myself, the over voltage or under voltage, through these two potentiometers. I am using these two potentiometers for increasing. If I will increase this value from here, you can see the value is increasing there. You can see value is increasing there, and the over voltage relay has been operated, so it's beeping. And when I will make it less, then it's coming under normal voltage. Since I have kept 220 voltage as over voltage, it's coming, if it's coming more than 220 volts, then it's showing over voltage, and if it's coming less than 180 volts, then it is under voltage. Then the second IC is for under voltage, this relay, then this LED glows, and when this relay operates through this relay driver. As you can see, I have operated this, I have changed my current, this as supply current from here. If I am getting any supply from here, then I am changing from this I am changing. You can make it normal. Okay, it has become normal. As you can see, this circuit, means this 12 volt supply I have used to show you that my over voltage is coming or under voltage is coming. This circuit I have used to show you that my over voltage is coming, under voltage is coming. This potential divider, this voltage regulator, this voltage regulator is dividing the 12 volt into 5 volts, and which is going into these two potentiometers. These potentiometers regulates the voltage, as you have seen now, just now. This potentiometer divides the current into 5 volt and 5 volt each, and this max 232, it is working from this potentiometer. It is taking current from this potentiometer, and it's working from here, this part. It's working from here, this part. It's also coming under this. This is also now coming under this. This also I've kept one capacitor here also, like here, because it smoothens the DC, so that I can get in the perfect 5 volt which I need. That's why I have kept these capacitors, and I have shown you the ratings on my circuit here, that you can see how much rating I have used here. This max 232 is used to run this port. This I've connected this port. You can see here I've connected this port. I have connected this port. This port is used to connect this port. That IC max 232 is used to connect this port. A serial to data convert, serial to USB converter I have used here. This prolific serial to USB data converter cable है, and I have used this. I've used this to connect to my PC. I've connected it to my this PC here. Sorry, laptop. And now I'm going to show you my simulation circuit. Sorry, this was the buzz. Once again, I want to show you my all that you can see circuit. You can see here. This is my circuit of. This is the circuit of max 232 and this COM pin which I have shown you just now, which is connected to my laptop. This is shown by this. It's a serial to USB converter cable I have used to communicate with my laptop. And I have made one circuit which will show you the current values. I'm running it in the proteus. When I will run it in the proteus, here you can see that as you can see here, it's giving 203 volt, and I have connected using this cable, this serial to USB cable, and the serial to USB cable, and I inserted into my this laptop, and this 203 voltage can be seen here because I have connected using Proteus. This is my Proteus software, and I have made the simulation circuit here, and I have inserted the codes here, so you can see 203 is also coming here. And I'm changing from the hardware. As you can see, it's showing 215 volts, and you can see now on the hardware also it's showing 215 volt. Now it's 216, 215, and now I'm again changing from here, and you can see the changes. 217 volts, 18 volts, and that 218 volts can be seen here also. As you can see, this I have my circuit. I have simulated with my hardware. This software I have simulated with my hardware, and these values are also coming, you can see here, but these values you cannot understand. These are coming in this virtual terminal. These are actually the ASC codes, and the programming of these ICs is stop this programming from here, and the programming code is this. I have chosen code space SCADA. I'm having many codes. I've written many codes from that code.SCADA, code space SCADA. This is my, and hex files are used to run in the proteus. This I'm going to open, and here OK, and when I will run this, then why this system comes proteus based fault detection, and after 2-3 seconds this will show the voltages which is on my hardware. As you can see, 218 was there, and now also 218 is shown here. Okay, so this was my project which I have made to detect the fault, of over voltage and under voltage. As I have shown you that these were my relays which are operating on over voltage and under voltage, and these are all the components, and this I have connected using this, and the software I have used was Proteus, and I have written this codings in this bascom. That coding I have saved and inserted in this. These are the codes which I have written here. Coding I have done. It was a very small coding, not very much long. This is the coding, and one more. I have used 2 codings, one for this, and another for this program, this, and these are the codings in which I have used in one of the IC, and the second coding I'm going to show you. This I have used in the simulation circuit. You can see here. It was a small coding which I have used here. Okay. Thank you guys, and have a nice day. All the best. If you want to, in this project I'm going to improve myself. I will improve later on, and this project is also having many benefits, such as we can detect faults over voltage and under voltage, and many faults using this proteus based system, and which can also be seen on our LCD screen, and the buzzer is beeping when a fault is occurring. That's all. Thank you, my friends.